Math Blast 17, distributive property. Show an array for 5 times 4 equals something using the distributive property. Well, I know that 5 times 4 means 5 groups of 4. When we're dealing with multiplication, we're talking about groups, equal groups. So I'm going to draw an array that shows 5 groups of 4. In an array, my rows are my groups. So here are my 5 groups, and I'm going to make sure that I have 4 items, or 4 X's in this case, in each group. Now, to show the distributive property, I'm going to break my array into 2 parts here. The top part of the array is 2 groups of 4, so 2 times 4. For a total of 8 X's. And the bottom array shows 3 groups of 4, or 3 times 4, for a total of 12 X's. And when I put these together, I know that I can find the whole 5 groups of 4. And so 8 plus 12 is 20. And so 5 groups of 4 is the same as 2 groups of 4 plus 3 groups of 4, which is 8 plus 12, which is 20. Patterns. What rule is the function machine using? The idea here is that this input number has something that's happening to it to get the output number. And to be the rule, it needs to be the same thing happening all the way through the table. So to get from 6 to 30, I know I could add 24, or I could multiply by 5. Let's see what happens to get from 10 to 50. I can't add 24, so that's out of here. 10 times 5 would give me 50, so that still works. And in my last row, 8 times 5 will still give me 40. So the thing that works, or the operation here that works all the way through the table, is multiplying by 5. So I'm going to state the rule as input times 5 equals output. Number line partitioning. Partition into 3 equal pieces and label each partition. So from 0 to 1 is the whole. I want to break this whole into 3 equal sized pieces. And I'm going to label each partition. So if this is 0, then this is 1 out of 3 pieces here. To get all the way to here would be 1, 2 out of 3 pieces. And to get from here to here to here, we would have 3 out of 3 pieces, or 1 whole. I can also call this 0 out of 3. Elapsed time. Write the time shown on each clock. When looking at the start clock, I want to remember that the shorthand tells me the hour, while the longhand helps me determine the minutes. So I'm going to look at the shorthand first, and I see that it is on the 11, but has not reached the 12. So we're still in the 11 o'clock hour. And when I look at the minute hand, I notice it's right at the top. So we've started the new hour here, 11 o'clock. When I look at the end clock, the shorthand has not quite reached the 1. It has passed the 12, but has not reached the 1. So we're still in the 12 o'clock hour. And when I look at the minute hand, it's at the bottom of the clock. Now, starting at the top of the clock is where 12 o'clock began. And then we are going to count. Each little dot is 1 minute, but we know that each number on the clock represents 5 minutes, so we can count by 5s. 5, 10, 15, 20, 25, 30 minutes has passed. It is 12:30. I'm going to call these both p.m. So from 11 o'clock p.m. to 12:30 p.m., how much time has passed from the start to the end? Well, to get from 11 o'clock to 12 o'clock, that's 1 hour. And to get from 12 o'clock to 12:30, that's 30 minutes. So 1 hour and 30 minutes has passed. Area. Find the area of the rectangle. Area is the square units that covers the inside of the two-dimensional figure here. So I'm going to finish tiling my rectangle. And I can count the square units covering it to figure out the area. 1, 2, 3, 4, 5. So there's rows of 5. 5, 10, 15, 20, 25, 30. The area would be 30 square units. Because I had 6 rows, and there are 5 columns, and so 6 groups of 5 is 30.